The HiDream i1 text-to-image generation model and HiDream e1 image editing model are among the best in the latest open-source diffusion models. The i1 model features 17 billion parameters, surpassing the 12 billion parameters of the most popular Flux 1 series in the community. It delivers outstanding image quality, great adherence to prompts, and is open-sourced for commercial use. I've used it to create some very interesting images. Its image-to-image style transfer capabilities are highly impressive, outperforming models like GPT-4o and Gemini. The E1 model is built on top of i1 and can edit images using natural language instructions. You can effortlessly add, modify, or delete elements in an image with just some simple commands. Currently, ComfyUI natively supports both models. By upgrading to the latest version, you can start using them without needing to install any additional plugins. Furthermore, ComfyUI recently separated its workflow templates into a standalone repository. If a model is natively supported, related basic workflows are now directly integrated into the template library, making it extremely convenient for early adopters. However, to fully unleash the potential of the models, relying solely on the basic workflows might not be enough. There are many details to consider. I'll demonstrate them in a moment. As usual, start by downloading the model that suits your needs. The i1 model comes in 3 versions: Fast, Dev, and Full. The full version is the complete model, while Dev and Fast are 2 distilled versions. Similar to the Flux Series Pro, Dev, and Schnell variants, these 3 models have identical file sizes and VRAM requirements. Additionally, all 3 i1 models are licensed under the MIT license, commercial use allowed, unlike the Flux series, where only the Schnell model is commercially available. So how should you choose between these i1 models? The strategy is simple. If you want the highest image quality, go for Full. It excels in prompt adherence, image detail, compositional robustness, and creativity, and it also supports negative prompts and CFG. However, generating images takes the most steps, 50 steps, which, truth be told, is quite slow. Dev and Fast, as distilled versions, are theoretically slightly weaker in performance but can utilize the LCM sampling method, requiring fewer steps and running much faster. E1, on the other hand, has only one version, Full. Its file size and requirements are identical to that of i1's full version, so there's no need to overthink this decision. Where to download? The official version offers split model files, but I recommend downloading the merged versions provided by ComfyUI, which total 7 variants. The original models, BF16/FP16, are 34.2 GB in size. Even with 24 GB of VRAM, running them can be quite demanding. However, ComfyUI provides FP8 versions, reducing the size to just 17 GB, allowing them to run on 16 GB VRAM setups. City96 and ND911 have also created GGUF versions for the i1 and E1 models, respectively. In theory, the Q8 variant has higher quality than FP8, with a file size of 18.7 GB. Just within the limits of a 16 GB VRAM system. For systems with 12 GB VRAM, you can opt for Q5_K, which is slightly weaker than FP8. For even smaller VRAM setups, you might have to consider Q4_K or even Q2 variants. This series of models requires 4 text encoders, clip_L, clip_G, T5_XXL, and llama_3.1. Among these, the first 3 may look familiar, as similar ones have been used in SDXL, SD3, and Flux. However, in reality, only T5_XXL can be reused. You can use the FP16, FP8, or FP8_scaled variant you already have locally. The HiDream series uses specific versions of clip_L and clip_G, so make sure not to use the wrong ones. You can download them from ComfyUI. The VAE files can be found in this folder, but they're the same as Flux's VAE, which most users likely already have. While HiDream officially provides its own VAE, using the Flux VAE doesn't make much of a difference. No matter which version of the model you download, you need to place it in the diffusion_models directory, although you can also place it in the unet directory. Recently, someone asked me about the difference between these 2 folders. In simple terms, unet refers to a specific network architecture, while diffusion models can encompass a variety of architectures. Most early diffusion models like SD 1.5 and SDXL were based on the unet architecture. However, as the diffusion model ecosystem has grown, ComfyUI now supports many new architectures. To improve clarity, the diffusion_models directory was introduced. For compatibility, the .NET directory is still retained, and ComfyUI will read models from both folders simultaneously. The clip and text_encoders directories follow the same principle. It's best to place any downloaded text encoders in the text_encoders directory. For VAEs, place them in the V directory. I opened ComfyUI to work with it. My local RTX 4080 has 16 GB of VRAM, and running FP8 and GGUF models isn't an issue. However, when screen recording software also consumes some resources, the VRAM gets maxed out, leading to slower performance. So, this time, I used a friend's ComfyUI environment for the demonstration. Let's get started. Open the manager and update ComfyUI to at least version 0.3.33 to ensure full support for I1 and E1 models. As a side note, I personally prefer switching to the nightly version from here. It allows for upgrading directly to the latest version. Once updated, head to the ComfyUI template library to find suitable workflows. The template library is hosted in a separate repository and updates as a Python dependency. Under the image section, select image-related workflows. The first row contains 4 workflows specifically for the HiDream models, corresponding to the I1 dev, fast, and full models, as well as the E1 full model. For this demonstration, I chose the I1 full workflow. After loading, a pop-up may appear if the system detects that local models are missing. You can click on it to automatically download the required models. However, I do have the models, it's just that their names and folder structure don't exactly match those in the workflow.s. Feeling confident, I just closed the pop-up. This workflow is very tidy. On the left is the section for loading models. Below it are the output dimension settings. In the middle is where you set positive prompts and shift values. There's only one sampler node, KSampler, which has a few complex parameters, but there's a helpful annotation next to it explaining how to configure them. First, select the model. The default is the FP8 version, but I'll begin by demonstrating with the original version, FP16. Switching is as simple as changing the model in that node. Next is the clip loading node. As mentioned earlier, HiDream has high requirements and needs 4 text encoders. Make sure to load all of them, clip_L, clip_G, T5_XXL, and llama. Note that T5_XXL and llama are quite large, so if your system doesn't have enough memory, greater than 48 GB, it's best to increase your system's virtual memory. For image dimensions, I kept them at the default 1024 by 1024 for now. This model is a bit particular. Small images at 512 by 512 tend to appear blurry, and it also struggles with very large sizes like 2048 by 2048. The sweet spot is a range between 768 and 1536 for width and height. Non-square images are fine too. I updated the prompt to generate a princess wearing an elegant dark blue velvet gown standing on a balcony. For negative prompts, the workflow comes with a few default words, but I prefer to replace them with my usual set of negative prompts. Since this is the full model's workflow, there's no need to tweak many parameters. To ensure reproducibility for comparison, I set a fixed random seed. Click Run and patiently wait for the results. If you're accustomed to using Flux, especially models like Nunchaku, you'll find that HiDream brings us back to generation times measured in minutes. The result is here, and I think it's excellent. The level of detail, lighting effects, and artistic style are all exceptional. Next, I switched to the FP8 model. It's a simple change, just swap the loaded model in the previous node to the FP8 version. No other parameters needed adjustment, so I ran it again. The sampling time was about the same as the original version, and the quality was also comparable. When loading GGUF models, you'll need to add an additional node. This is part of City96 ComfyUI GGUF plugin, which can be installed through the manager. I chose the Q8 version of the model, replaced the prior model loading node, kept all other parameters the same, and ran it again. Now, look at the results. I don't see much difference, but the Q8 model can run on a 16 GB VRAM setup, so it's what I'll use for subsequent demonstrations. The i1 model performs exceptionally well for generating stylized images, especially in scenarios with strong artistic or visually striking elements. I tried updating the prompt for an impressionist-style painting. After running it, and skipping the long wait, the result was fantastic. It looks like something you could frame and hang on a wall. The i1 model is also great at adhering to prompts and generating text. I changed the prompt to ask it to draw, "Nice to meet you." The result? Every character was clear, and even the reflection of you in the street scene was precise. Wanting more text, I updated the prompt for another test. This time, it generated 2 sets of differently colored text, "How are you?" and "Fine, thank you." "And you?" Each letter was perfectly rendered. I used the same prompt to generate some other text-based images, and the results were consistently reliable. In addition to its performance in text-to-image tasks, the i1 model excels at image-to-image transformations and stylistic re-rendering. To test this, I added an image loading node to upload a photo of a handbag. Using the VAE encode node, I encoded it into a latent space and passed it to the sampler. I updated the prompt to a handbag made of crystal. I started with a denoising strength of 1 to verify if the model understood the prompt. It generated a crystal handbag, so it's clear the model knows what I meant. Next, I lowered the denoising strength to 0.7, which allowed the new image to retain most of the original image's features. For even closer matches to the original, you could lower it further to 0.4 without issue. I also reduced the step count to 35. After running it, the handle and pendant transformed into crystal, but the body of the handbag didn't. From my experience, the i1 model exhibits significant variability depending on the random seed. I unfixed seed and tried again. This time, the handbag's body transformed completely into black crystal. I changed the prompt again, and it had no trouble generating a marble handbag. You can experiment with various materials. I've successfully created chocolate, yarn, Lego, and leaves as handbag textures. Let's try something more practical: style transfer for portraits. First, upload a portrait of a young lady. It's a vertical image. Use a simple prompt like anime style, keep the denoising strength at 0.7, and click Run. I'm very satisfied with the output. The result looks fantastic. Next, let's try something a bit more complex: a young lady blowing bubbles. This one is more challenging. Simply using the same simple prompt as before won't work. I'll fix the seed in advance so we can better observe what adjustments are needed. After running, I got an image where the model retained the pink bubbles but added a mask that wasn't in the original picture. How do we fix this? It's actually quite straightforward. Don't be lazy. Just describe the scene thoroughly in the prompt. At the same time, I changed a young woman to a young anime woman for a bit more stability. Run it again, and the result is perfect. That's it for the i1 model. Now, let's return to the template library and test out the e1 model. Open the built-in e1 workflow. As with i1, it notified me of missing models, but I confidently closed the message. During the explanation of the i1 model, you should already know how to load both the original FP16 and FP8 models. For this demonstration, I'll directly use a GUF-Q8 model. Add a UNet loader, GGUF, node, select the local model, and replace the previous model loading node. In the clip loader node, select the 4 required models from your local files. Upload the same image of the young lady blowing bubbles. The example images provided for the E1 model showcase a variety of use cases, such as changing colors, modifying styles, replacing subjects or backgrounds, adding text, and removing content. Let's test a few of these. We already saw that the i1 model did well with full image style transfers. Let's see how the E1 model performs. For models designed for editing rather than generating from scratch, you typically need to input a specific command, telling the model what changes to make. For instance, the prompt in the example workflow says, "Give the girl VR glasses." However, this approach runs into the same issue we saw earlier with i1 style transfers. It's hard to preserve the bubbles the girl is blowing. How do we solve this? You can use the format demonstrated in E1's official documentation, which includes both the modification command and a full description of the final image. To generate prompts like this, you can use an official prompt optimization script provided by the E1 team. This incorporates instructions from a large language model, LLM. While the official script uses GPT-4o, the instructions are actually quite simple. Any multimodal LLM capable of image interpretation should work. I used Gemini for this test. After uploading the image and specifying the modification, the model produced 3 outputs: a description of the original image, the specific command, and the final expected outcome. Take the last 2 outputs, transform them into the required format, and place them into the prompt field. It looks simple enough that you could write it manually if needed. For the full model, negative prompts are still very important. They significantly impact image quality. I strongly recommend adding them. I fixed the random seed for easy comparison, left other parameters untouched, and clicked Run. The result is here, but I'd say it's mediocre. While the anime style works and the pink bubbles remain, the character has been noticeably stretched. Looking back at the official examples, they have the same issue. It's far inferior to what we achieved with the i1 model using style transfer in the image-to-image workflow. So, if you want to perform full image style transfer, I'd still recommend using the i1 model. Now let's try removing the final image description in the prompt to see if we can simplify the process. Run it again. And as expected, it doesn't work. The pink bubble is gone. But when I add the description back, everything works fine. Now, let's add a hat to the young lady. Following the same method, modify the prompt. The instruction is to add a hat, and the description becomes a woman wearing a hat blowing pink bubbles. After patiently waiting, the result with the hat is decent. The character, background, clothing, and hair weren't altered. However, upon closer inspection, the overall colors seem a bit off. For example, the bubble, originally light pink, now looks somewhat out of place. This is one of the disadvantages of the E1 model. However, we can fix this using the color matching node in KJ nodes. Add a color match node. You don't need to change the model, and as for the strength, I typically use 0.6. Click Run. Since the seed is fixed, there's no need to resample, and the result comes out quickly. Doesn't it look much better now? When using this, you can experiment with different models and parameters to achieve a color tone closest to the original. Of course, in some cases, like when you've made a significant modification to the image content, the overall tone of the image may naturally change. In such cases, the unadjusted output might actually look better without color matching. Let's change the prompt again, this time, turning the bubble's color to green. Click Run, and as we can see, the initial output isn't great. Only after color correction does it become more visually acceptable. If you look back at the official example, even the red hair on the young lady looks inconsistent. The same issue occurs when changing clothing colors. The initial output isn't good, but the results become acceptable after color correction. Now, let's try modifying some text. Switch to an image of a kitten holding a sign. I want it to say, "How are you?" Modify only the prompt, keeping all other parameters at their defaults, and let's see what happens. It seems that as long as you're not changing object colors, the output's color and brightness remain unaffected. The text modification to "How are you" is a success. Erasing text is even simpler. Using this prompt, the final output looks like this. Next, I'll try removing the flock of sheep from the background. The prompt reads accordingly. And the result is great. The meadow is still the same meadow, but the sheep are gone. However, comparing the image before and after color correction, there's an obvious difference. Finally, let's try a more challenging task. Replace the cat with a dog in the prompt. This is a much bigger modification than the earlier ones. Looking at the output, after color correction, the result looks acceptable, though the cat paws weren't changed. I won't do any more demonstrations now. You should be quite familiar with the capabilities of the i1 and e1 models by this point. Let's start with the drawbacks. 1. High hardware requirements. The models are exceptionally large. The original version is 34.2 GB. Even if you have a 24 GB RAM RTX 4090, I'd still recommend using the FP8 or GGUF versions. For those with 16 GB VRAM like me, it's best to choose the GUF Q8 or Q6_K versions. 2. Slow generation speed. The full model requires 50 sampling steps, and it's not fast. Even with the fast and dev versions, which support LCM sampling methods, they're still much slower compared to models like Flux optimized with Nunchaku. 3. Usage limitations. Especially with the E1 model, it currently only supports input images at a resolution of 768 by 768. It doesn't support masks, and there are often changes in color or brightness that require subsequent correction. 4. Underdeveloped ecosystem. The ecosystem is relatively immature, likely due to the high hardware requirements. Currently, there are only a few LoRa's available, and there's no sign of support for ControlNet. That said, the models are still incredibly useful in certain situations. The I1 model excels in prompt compliance and rendering text, outperforming Flux in these areas. It's well suited for generating highly complex images, and its style transfer capabilities in image-to-image workflows are excellent. The E1 model performs well in specific scenarios, making image editing more efficient and saving significant time for certain tasks. Alright, that's it for today's video. Links to the models, workflows, and the plugins mentioned are all in the description. Feel free to explore them on your own. See you next time.